In this example, we learn how to make forecasts for time series data that have some kind of trend. Here we have bicycle sales data for 10 years, and we would like to predict the sales for the next couple of years. First, let's plot the data to see if there is a upward or downward trend in the sales. So we'll create a scatter chart with two variables, year and sales. What we do is we select the two columns. Year is going to be the X on the X-axis, and the sales will be on the Y-axis. Now we go to Insert, Scatter, and then click on the first one. So here it is. You can see that there is some kind of trend, and it's the sales are mostly increasing. Now, sometimes it goes down, but mostly goes up, and it looks like it might be reasonable to try to fit some sort of line on the data for the pattern. So we could fix up this chart a little bit. For instance, here we could see there's a lot of blank space, so maybe we could get rid of it by making the y-axis start with a 15 instead of 0, and then maybe go from 15 to 35. And we could do that by right-clicking on this area just to the left of the y-axis, and then going to Format Axis, and we could see here you got the minimum and the maximum we could specify. So we are going to fix the minimum and the maximum at 15 and 35. Okay, so here is the result, and I could maybe delete this little legend here, and I could maybe put some title on the chart, maybe titles on the axis, and we could do all that by going to layout. So you could see there's axis titles and the chart title. Work with a chart where that's already been done, which you already have down here. Here's the same chart with the axis titles and the chart title added. And what we try to do is we try to draw a kind of line that kind of fits the data. And there are many possible straight lines you could draw, but we want to find the best one. So let's see, the line might perhaps look something like this. And once we find this line, then we could say, well, let's see, year 11. Here is the predicted sales, year 12, and then here is the predicted sales. The best line is found by linear regression. This is a kind of line that will yield the smallest sum of squared errors. By error, we mean the distance between the data point and the estimate that is on the line. So this part will be the error. Now, as in the mean squared error, we would square these errors and for each data point, and then add them up, and that will be the sum of these squared errors. Okay, and what the regression method does is that it'll give you the line out of all the possible lines. It'll give you the line that will give the smallest possible sum of squared errors. So the equation looks something like this. Y is equal to intercept plus slope times x, and of course y is over here and x is over here, and the intercept will be where the line crosses the y-axis, like over here, and the slope of course tells you how steep this line is, that is the rise over run kind of thing. Now in the trend projection, x is actually the like time periods, like the years, and so we're going to call it little t for the time periods. Okay, so x will be the little t, and the y will be the sales, and we're doing a trend forecast, so we use the letter big T for y, so it becomes something like this. And intercept, we use the notation b sub 0, b with the subscript 0. Then slope will be b sub 1. So the trend projection line looks like this. T is equal to b sub 0 plus v1 times the the small t. So now what we need to do is find the intercept and the slope. Once we have these numbers, we have the equation for the line, so we could plug in the year we're trying to predict here for the little t, and that will give us the forecast we're looking for. And there are several ways of finding the intercept and the slope. Well, I'll show you two ways. Here is one way. We could use the intercept and the slope formulas that are available in Excel. What we do is we just type the whole word intercept, and then it says here, first you gotta put in the known y's, comma, and then the known x's. Here the y values are the sales, and the x values are the time periods, that is the years. So this is the order we need to go by, and that ordering is very important. Important to put the y values before the x values in this formula. Okay, and then entering gives us 20.4 for the y-intercept. So, that looks reasonable, right? From here. The slope is just enter the whole word again, and the same thing. First the known y values, comma, and then the known x values, close, and there it is, 1.1. We have the intercept and the slope, and we're going to write it right here. So t is equal to 20.4 plus 1.1 times little t. So that's our equation. And now we could plug in values here to make the trend forecast. So for here, 11 and 12 and 13, and then the trend forecasts are, we just plug in the numbers, 20.4 plus 1.1 times 11, and that gives us 12.1 plus 20.4, giving us 32.5. And similarly, year 12 is 20.4 plus 1.1 times 12, and that part is 13.2 plus 20.4 gives us 33.6, and so on. In Excel, we could also use formulas as shown here. So intercept, click on the intercept, then plus, and then reference the slope, 1.1, and don't forget the dollar signs. We're going to copy these down. We're going to copy the formula down, then copying down gives us the forecast for the next 3 years. I would also like to show you how to add this kind of trend equation on the scatter chart itself. I'm going to ask Excel to put in the trend line and also the equation. What I do is click on, right click on one of the data points, and then you can see there's a add trend line on the menu. Select that, and then you could see that you could even choose a different kind of regression line in addition to the linear, the straight line, but we'll stick with the linear for today. And then here you have display equation and chart options, so we want to click that. And if you wanted to display R-square value, you could also do that. Oh, why not? Let's do that. And then we say close, and you could see here we have the equation and the R-square value. Y is 1.1x plus 20.4. You could see that 20.4 here, is the intercept, and 1.1 is a slope. It's just that the two terms are in different order, but it's the same expression. As you might recall, the slope here, 1.1, has a special meaning. It gives you the increase in y per 1 unit increase in x. So 1.1, this 1.1 is how much the sales increases when the year variable little t is increased by 1. So if you were to ask, on average, how many more bicycles would you be able to sell next year compared to this year? what would you say? Well, you would say, well, 1 more year means that the sales will increase by 1.1. Now, what is 1.1 in terms of number of bicycles? Well, here the sales are in units of thousands, so we would say 1,000 times 1.1. So we would say that every year we would expect to sell about 1,100 more bicycles. So 1,100 would be considered the annual growth rate in sales in terms of number of bicycles.